My notes say that we got through 14. Tell me again how we're going to do 14. Conceptually. You don't have to solve it. Just tell me what we're going to do.
Okay. Is this the last question on that no calculator part?
I'm sorry, what? Oh.
Is this the last question?
You don't need a calculator for that.
Okay.
You can tell by the fact that everything is a small number. Where you use calculators is when they give you numbers like 325,016.
Yeah.
You know you're going to need a calculator. There is no number here greater than 12.
Yep.
So whether it's a calculator section or not, you don't need a calculator. Remember what the key is.
For this one, do you have to know what x and y is? Like, do you have to solve for it?
Well, no, you don't. However, you recognize what 8 and 2 have in common.
Do we simplify it?
Well, you recognize that they have a common exponential base.
Right.
In other words, I can write 8 as 2 cubed, and I can write 2 as 2 to the 1.
Mm-hmm.
Okay? And what that means is this is 2 to the x, 2 to the y. Now simplify that. Use your rules of exponents.
When they're multiplied, you add them.
Hold on. Let's take this one first. That is exponentiation. What is one level less than exponentiation? Think multiplication. In other words, it goes addition, multiplication, exponentiation.
Okay.
So that's since we're doing exponentiation, we're going to multiply the exponents. So that equals that. This is still. Okay, now we're dividing. Same base, different exponents. What are we going to do to the exponents?
So 2.
What'd you say?
2. I'm so bad with exponents. Oh my gosh.
Well, you shouldn't be, because it's really easy. Whatever you're doing to the base, one level less. So we're dividing the base. What's one level less than division? Subtraction.
Okay.
Addition is one level less than multiplication. Subtraction is one level less than division. And multiplication is one level less than exponentiation. Those are the only 3 rules you need. That's it.
Okay.
2 to the 3x, 2 to the y, subtract the exponent. Now notice what they told us what that's equal to.
Oh, okay.
And there's a reason. In other words, we're almost certainly going to get 3x minus y there. Okay, so now that's 2 to the 12. Answer A. Got it?
Yeah.
All right. Let's go to 2. This is no calculator part of the test. When do you take the test, Abigail?
I believe May.
Okay. Because I want to have at least one session where I go through the PowerPoint presentation on the entire essay, and I talk about the English, the verbal, and the math. And I think that might be valuable. Even if you've done really well on the verbal part and you're weak on the math, we definitely want to focus on the math, but there's some awfully good tips. I give 5-hour seminars on the SAT, covering all 4 tests. And so even if you're good on the verbal, it might be helpful. But I have to do that on a different computer, and today is not today. So maybe next time I schedule a session, I'll do it on my laptop, and then I can pull up that PowerPoint presentation, and we can spend at least one session going through that. You haven't attended those, have you? Have you attended one?
No, I haven't.
Okay. One of the common, I work for Sycamore Learning Company that does a lot of the high school and the Front Range. There's a couple of them. I'm sure they're all good. They definitely give you tips that are worthwhile enough that you could dedicate a whole session to covering them.
Okay.
All right, let's look. Are you hearing an echo?
A little bit.
Let's try something. Log off, log back on under the same ID.
Okay.
Let's just see if it helps.
Okay.
Abigail? Abigail, can you hear me?
Yes.
Okay. I'm still getting a bit of an echo. It may be that I have to log off and restart GoToMeeting and send you a new meeting ID number. If I remember right, we had this problem last time also, is that correct?
Yeah.
You remember? Yeah. Okay, I can work over it. As long as you're not hearing an echo on your end, then it's...
No, it's a bit better.
Okay, it's only my problem. And I can ignore my echoed voice that comes back about a second later. Okay, so looking at 15. Without going any further than right here, hold on. What's the first thing we're going to do? You don't even have to read the rest of that problem. In fact, reading the rest of the problem is confusing until you figure out what to do with the part that I've underlined.
Yeah. Factor that first part?
Well, you don't mean factor.
Or just like
FOIL.
Okay, yeah. I'm
Okay.
not too familiar with that line.
Well, When I say FOIL, I mean, I don't really like the term FOIL because it doesn't work with trinomials, but it works fine with binomials. Basically means multiply every term by every term. So what do you get? You multiply the left by the right.
So ax times bx,
What
ab x squared.
Okay. That's the first term. What else? The second term. Outside.
Then do you do the 7 and 8x?
Okay, so that's 7ax. Just give me the terms.
And then 2bx.
Keep going.
And then 14.
Okay, plus 14.
Yeah.
Plus sign. Okay, so that, let me go over here and rewrite that, just so we'll get an idea of what we're looking at. I can put everything in there. That's equal to 15x squared plus cx plus 14. Okay? So, if I look on the left side, there's only one x squared term. What does that tell me about AB?
About AB?
What's AB have to equal to? If you look at this entire equation, ABx squared has to equal 15x squared. There's no other x squareds on the right, and there's no other x squareds on the left. So I know for starters that AB equals 15. That's one equation. Now, the middle term, if I look at that and factor out an x, I got this. Correct?
Yeah.
So what does 7a plus 2b have to equal?
C?
Yeah. In other words, it's called equating the coefficients. Okay? This part here, 14, crosses off. So I've got these two equations up here. I'm not going to erase the bottom one. May need it. What else do they tell you? And a plus b equals 8. So let's add that. A plus b equals 8. Now, the question is, can we solve for c? Well, if I'm going to try to solve for c, I got to figure out what a and b are, right? Okay. So let me put some room here. I'm not going to really need that. There's one equation with a and b. Here's another equation with a and b. No c. Solve those two equations.
It would be 3 and 5.
Yeah, okay. You did that in your head as opposed to the way I would rather see you do it. In other words, you can do that when it's simple. It's actually 3 and 5 and 5 and 3. So there's two solutions for a and b. But the way I'd like to see you do it is solve the first equation. A equals 15 over b. Substitute that for a, so you have 15 over b plus b equals 8. Well, now if I multiply everything by b, I get this. That's a quadratic. That's going to give me two solutions for b, which are b squared minus 8b plus 15. You don't recognize what I'm doing, please stop me and say, how'd you get that?
Okay.
Okay. Well, that gives you b minus 3 times b minus 5 equals 0. So I got two solutions for b. B can be 3, B can be 5. Obviously, A can be 5, and A can be 3. So I got this solution, and I got this solution. Now, does it matter for C? They want to know, what are the two possible values of C? Well, notice this, all I got to do is plug in my two values into this equation that I have circled, and I'll figure out the answer. So let's start with the first solution, which was 3 and 5.
Okay, b equals 3 and a equals 7 times.
What's that C solution?
41.
Do we need to do any more work?
No.
There's only 141 on there. That's got to be the end. We're done with the problem. In other words, there actually is a lot more work to do if we had to solve it. If we didn't have a multiple choice, or if there were two 41s on there. In other words, we need to resolve for C if B is 5. So now I have 7 times 3 plus 2 times 5. That's 1031. Well, that's the other half of that. But notice we did not need to do that.
Right.
And that's an important realization when you take the SAT, is to realize what you need to verify and what you don't. And in general, checking is not advised. In other words, if you solve a quadratic, be comfortable with your solution. Don't take the time to multiply the two back together again to make sure it equals your quadratic.
Okay.
I don't know if you've been following this college admissions scandal.
No.
You don't know about it?
No.
Well, it came up about 4 days ago. Been in the news quite a bit.
Okay.
But they had students on TV telling how they prepared for the SAT. And the best preparation I've heard ever is what the following girl said. A month before the SAT test, she forced herself to get up at 7 a.m. every Saturday and took a complete practice SAT. For 4 Saturdays prior to the Saturday she was going to take it. I've never heard of anything as good as that.
Yeah.
I told all of my SAT students to use these practice tests. They're vital. And I tell them, don't go home and do them all in one day. Spread them out. But the best way to spread them out is to duplicate the time. In other words, this is going to be a very stressful time when you go take that SAT test. No avoiding. The best thing you can do to get comfortable with stress is to make it so that it's not the first time you encounter that. Figure out how you're going to eat breakfast that morning. Are you going to have a cup of coffee? Things like that. This is a very important test. As this admissions scandal is showing, people are paying $100,000 to teach on the SAT test to get their kids into college, which merely points out the importance of this test.
Yeah.
Okay? Let's see, that was 15. We did 14. Okay, we're off to a new part of the test. That's good. That means 15 was as hard as they get.
Okay.
Do you have any questions about the grid end?
No.
Is this acceptable? Hold on a second. I'm going to give you a couple of examples. The only question you might have is putting in an incorrect answer, or putting in a correct answer and an incorrect manner. If my answer is 0.66, I cannot do this. That's not acceptable. I'd have to do it 0.666. In other words, if you're going to use a decimal point, make sure that the first, and there's no number in front of the decimal point, make sure that the decimal point is in the far left column.
Okay.
Notice they did not, if I were to try to put in this answer here, there's no 0 in that first column.
Right.
If you look down here, there's no 0. That's missing. That means you cannot put 0 in the first column. Ever. Doesn't matter what. How about, how would you input that?
2.33.
Okay, that's one way to do it. The other way would be that way.
Okay.
The only way you cannot input it as a proper fraction. In other words, if you tried to input it like this, it would read that as 21/3, not 2 1/3.
Okay.
Okay. All right. Remembering again that we're back to the, in other words, question 16 should be easy. Solve that.
T would equal 2.
Actually, t equals plus or minus 2.
Okay. Yeah.
Right? In other words, if I have an equation t squared equals 4, and I'm solving it by taking the square root of both sides, the left side is t, the right side is plus or minus 2.
Okay.
Now, they did have to specify that t was greater than 0. So in this particular problem, the answer is not plus or minus 2, it's plus 2. But that won't always be the case. You're definitely going to have to face the situation where you have a plus or minus answer, which is what you get when you solve that. All right, look at 6. Let me scroll down a little bit. Get the answer. Oh, there's no answers. Right? Let me scroll down. Hold on. There. Yeah, there's no answers, but there's lots of I want the value. Let me put it like that. See it?
So these ones, it's not multiple choice?
No, this is the grid. other words, the next 4 or 5 questions, if you don't see multiple choices, you know it's a grid.
Okay.
Now, I know 17 looks hard, just when you just glance at it, but it isn't. We know it isn't. It's the second question of the grid end. It's relatively easy. So,
Yeah.
now, all of the information in the paragraph can be written on that diagram. And that's what you do. Okay? So,
Okay.
AB is 18. In other words, there's no restrictions about drawing in the paint. EB is 1400. BD is 700. And CD is 800. Now we have something to work with.
Okay.
Now let's read the rest of what they put in there. Segments AC and DC, angle AB, which is this angle, is the same as this angle. What does that tell you about AE and CD?
AE and DC.
The fact that E is the same as angle D tells you a very important fact about the lines AE and DC. Excuse me?
That they're, does that have to do with them being parallel?
They're parallel. Yeah. That's the very definition. In other words, they are acute interior, alternate interior lines of the transversal. All right? There's my transversal. A, B, and DC certainly look parallel when we look at it. So, but they don't say they're parallel. But it's all they need to do is tell us that angle E equals angle D, and that makes them parallel. There's no way angle E can equal angle D without them being parallel. Okay? Now, if they're parallel, and that angle equals that angle, well, how about this angle? That's got to equal that angle, right? The vertical angle.
Mm-hmm.
So if two of the angles are equal, all three of them, right?
Right.
Every triangle has 180 degrees worth of angle. So if you have two of them equal, the third one's equal. What does that mean about those two triangles?
If all three of the angles are the same, or add up to.
What does that mean for the two triangles? Triangle A, E, B is what to triangle C, D, B. There's a relationship between them. What is it? Are they congruent?
Yeah, they're the same, but they're just different sizes.
Congruent means they're the same size. These clearly are not the same size. But they are something else. There's another way to relate triangles. They're similar.
Yeah.
Similar basically means they have the same three angles and the same shape. One's bigger than the other.
Okay.
But the most important thing about similar triangles is that when you have two similar triangles, the ratios of the corresponding sides are the same. So what is the ratio of this triangle to that triangle? Find a corresponding side and figure out what that ratio is. How much bigger is the triangle on the left than the triangle on the right?
The triangle on the left is double the size.
Yeah, you're comparing 1400 to 1700. Now, let's be careful when we say how much bigger, because I don't mean area. I mean, how much bigger is a corresponding side of the bigger triangle to the corresponding side of the smaller triangle? And that is 2 to 1.
Uh-huh.
So what is AE? That's what they want.
1600?
Yeah. Now, whether that's an easy problem or not could be argued, but actually it is, as long as you remember your geometry. There's not a ton of geometry on this AP, but there's some. And the problem is it's probably been 2 years since you took geometry.
Yeah, sophomore year.
So the longer you've been from your geometry course, the harder the geometry problem. Whereas if you're taking trig, this trig problem is probably going to be a piece of cake. So be aware of that. And if it has been, if you feel your geometry is a bit weak, I've got some questions that a parent cut out all the geometry and pasted them into one test. So I have a test of just geometry from the SAT. And we could go over that one session if needed. Because this is supposed to be an easy problem. The second problem in this gridding section. All right, go on. To number 18. Oops. 18 is up here. System of equations, algebra problem. You're going to get at least 2 of these types of questions. We've already had one. Right? One that talked about what value would cause infinite number of solutions, or what value would cause no solutions. So we know there's going to be at least 2 problems on system of equations. What's the best way to solve this?
Elimination?
Yeah. How are you going to eliminate something?
I would multiply that top equation by -2.
Remember one thing. You are allowed to add or subtract equations. You don't have to alter.
Okay.
Notice that if I subtract them, X disappears. I don't need to do that first step.
Okay.
But do I want to take equation 2 minus equation 1, or do I want to take equation 1 minus equation 2?
Equation 2 minus equation 1.
That's what I would do, just because it comes out nice and simple as a y.
Yeah.
Now I can do minus 25 minus 90. In other words, I got that minus that. What's that number?
-16.
Now, we call for y. They want x. That was the only disadvantage in doing it the way I did it, was that I knew I was going to solve for y. So how do I solve for x?
You just put the y into the equation.
Which equation?
Probably 1, because it'll be
1
easier.
with the smallest number. So x plus a negative 16 equals negative 9. What's x equal to?
7.
So, in fact, it might have actually been easier to do the problem the way you wanted to do it in the first place. You wanted to multiply the top by negative 2, correct?
Yeah.
Now, the bottom is x plus y equals minus 25. Now I can add them to get minus x equals minus 7, which gives me x equals 7. That's probably fewer steps than what I did. So, in reality, because they were asking for x, each step makes the most sense as a first step. Had they been asking for y, then my step would have been faster, a lot faster.
Okay.
Okay? I don't know that that particularly matters. It's going to make maybe a 20-second difference depending on which way you went. Maybe it's not enough to worry about.
Okay.
Every 20 seconds. Do you know this?
19?
Yes.
Okay. One angle measures. What is the zero power? Is it just 1?
That's actually not zero power, that's degrees. One angle measures x degrees. Whenever you have a trig function in front of something, that's an angle. Take trig functions of angles.
Okay.
Okay?
Where x equals 4? Oh, I don't remember cosine or sine.
I'm going to tell you a very important property of trig. And that's the cofunction. What's the cofunction of sine? The answer is you take the sine and you stick the co in front of it. Yeah.
Sorry, you cut out.
Take the sine, you stick the word CO in front of it.
Cosine.
Okay. That's the cofunction of sine. Turns out cofunctions always have this property. What is the cofunction of tangent? Take the words tangent and stick a CO in front of it.
Cotangent.
That also has that property. And what is cofunction of secant?
I don't even know what that is.
Well, you probably but you've probably just had the 3 main trig functions. Maybe not. No, you probably had sine, cosine, and tangent.
Yeah.
But these other 3 trig functions are related to the first 3. Anyway, the cofunction of secant is going to be what? You can tell me. What is it?
I should put a co in front of it.
Cosecant. And that's written like that. And that also has that property. Okay? And it works the other way around. In other words, up here, cosine of x is equal to its cofunction, is sine, 90 degrees minus x. Okay? So, if you memorize the cofunction property, and the most important property of cofunctions is that the trig function of an angle equals the cofunction of 90 degrees minus that angle. Okay?
Okay.
Now, notice how valuable that's going to be to this problem. If the sine of x is 45, what's the cosine of 90 minus x? I didn't mean 45, I mean 4 over 5. Remember this property. All cofunctions have this property.
Okay.
And they're telling us this is 4/5. The other side happens. Equal sign right there.
Okay, so it has to be the same.
Yeah, it has to be 4/5.
Okay.
In other words, we didn't have to do anything at all on this problem. We just had to recognize the properties of both functions. It's worth memorizing. Because if you had that memorized, this is a 5-second problem. If you don't have it memorized, you could spend 3 or 4 minutes on this problem.
Okay.
Right? Because this is a hard problem to solve. Really. I mean, you have to draw a triangle, label X, and then know that that's 4 over 5, which makes this 3 over 5. 3 rather. And then 90 degrees minus X, let's put this angle right here, Y. So what's the cosine of Y? 4 over 5. Based on SOHCAHTOA. In other words, there would have been a way to solve it, even if you didn't know the property of cofunctions. You don't need a trig course. What you mainly need to solve these trig problems are the knowledge of SOHCAHTOA. As long as I knew SOHCAHTOA, I could have solved that problem.
Okay.
And the fact that in a right triangle, X and Y are always complementary. Right? The two acute angles always add to them.
Yeah.
Number 20 here. Let me scroll down a little bit so we get a little bit more writing room. All right. What is the value of X? Now, notice the last problem of the grid end. So this is maybe going to be hard. They don't have that much grid end problem. They go from 15 to 20, I think. So they only have like 6 of them. So you're probably going to have 2 easy, 2 medium, and 2 hard.
Okay.
Since they're at the value of X, which of these should I start with? That or that?
The second one.
Yeah, it's got the X on it.
Mm-hmm.
Let's solve that for X. Or we could solve it for A, which might actually be easier. Let's try both ways. Solve it.
Okay.
Solve it for A.
Okay.
This one right here, really easy. There's only one step.
Okay, you just put the 5 square root
Divide both sides by 2.
Oh, okay.
That's what you're doing. Dividing both sides by 2. Okay. Now we can go into this equation where we can substitute this for A, and then we'll have nothing but X and numbers. In other words, for A, we're going to substitute square root of 2x over 2. We know that's equal to 5 root Now this we can solve and we get an answer that's a number. So let's solve that. I think that's the best way to do this problem. In other words, we got it down to this. Now solve that.
Square root of 2x over.
The one thing you want to practice on is your algebra. There's 50% of the math test no, 60% is algebra. 20% is geometry, and maybe 20% is. But the algebra is the heavy part. If you have a weakness in algebra, it's going to hurt. You can't not be able to solve this problem.
Okay.
First step.
Is there...
In order to solve algebra equations, you need a methodology. You truly do. You can't just solve them hit and miss. Okay? My methodology is I get rid of denominators or parentheses or exponents. That's always my first step. That's what we have here. We have a denominator. Get rid of them.
So you would multiply both of them by 2.
Okay, what does that leave you?
The square root of 2x equals 10 square root 2.
Okay, hold on. Just making room so we can solve this thing going down vertically. Now what? I'm trying to solve for x, and it's important to have that x under the radical sign. You can see that that's where it belongs. It's not outside the radicals. So what's the next step? Get rid of radical. How do you get rid of radical?
We're getting rid of the x?
No, we're getting rid of the radical. We want our final answer to be x equals something, some number. Right?
Right.
In order to do that, we got to get rid of everything that's near the x. We've got a radical sign that we got to get rid of, and we got a 2 that we got to get rid of. That's the way to look at solving algebra equations. What do you have to get rid of so you can end up with x equals something? How do I get rid of the radical?
You square root.
No, you square both. Right now, square root. If I'm trying to get rid of the square root sign, then I'm going to square. I'm going to square that side, and I'm going to square that side. When I square the left side, what do I have? You have whatever's inside the radical, always, no matter what it is. It could be something super complicated. It doesn't matter. When you square a square root, you are left with whatever is inside the radical. Now square the right side. You have to square both numbers. That 2 applies to both the 10 and the root 2. What's 10 squared?
100.
And what's the root 2 squared?
Just 2.
Now, what's the last step?
So it would be 2x equals 200. X equals 100.
Correct. And that's how you do it. Okay. All right. Let's we got about 10 minutes. The next section of the calculator. Now let me add, just because you're allowed to use a calculator doesn't mean that you should always use a calculator. Okay? There are a lot of problems that actually a calculator tends to lead you in the wrong direction. There really are. And so sometimes using a calculator can actually slow you down. I have multiple problems I could demonstrate that with. But, so be careful. If you are good at arithmetic, you probably don't use your calculator very often. And by being good at arithmetic, I mean single-digit arithmetic. I don't expect you to know what 13 times 26 is. You'd use the calculator for that. But I do expect you to know what 63 divided by 9 is without a calculator.
Right.
All right. So let's have a look at this problem on the left, which I can't even see because I can't see the number. But it says John runs at different speeds as part of his training. The graph shows his target during his workout. Remember, this is going to be an easy problem. The first problem of the calculator set. On which interval is the target heart rate strictly increasing, then strictly decreasing?
What interval?
What's it doing?
It's increasing, and then it's the same, and then it decreases.
Correct. What's it doing here?
Increase, then it's steady.
Same thing.
Yeah.
And yet it says, what interval is it strictly increasing, then strictly decreasing? Kind of rules out those first couple. You circle. It looks like this has got to be that one. It's strictly increasing, it's strictly decreasing, then it increases again and then flattens out. But notice the answer is between 40 and 60 minutes, which doesn't cover that entire section. It covers this part right here. That's what happens between 40 and 60 minutes, which is strictly increasing, then strictly decreasing. So this was an easy problem, but they were trying to fool you. They fooled you by making none of those three fit that. None of them are strictly increasing and then strictly decreasing. But part of this one, and that's the part that fits this answer, 40 to 60 minutes. Okay?
Okay.
Let's see, that was 1. Let's go to 2. We expect this to be relatively easy.
Okay.
Here's the key. When y is equal to 24, x is equal to 6. What does that mean I can do?
So y equals 24 when x equals 6.
Okay, plug in both of those.
Okay, so it'd be 24 equals k times 6.
Now, what does that allow you to solve for?
K.
Okay, so what is k?
4.
So, the specific equation is y equals 4x. That's the way you do these problems. You're always looking for k in the first step. Now that I've got a particular solution to this model, what's the value of y when x is
20.
They're always like that. Always solve for K first. Once you solve for K, you're going to be able to answer the second part of it.
Okay.
Got time for one more. Do number 3. The two lines that are parallel are the ones you would expect. Oh, all 4 of them. In other words, S is parallel to T and L is parallel to M. And angle 1 is 35 degrees.
Okay.
Angle 2.
So they're what's the word? They add up to 180. Is that supplementary? Yeah.
So what's angle?
So angle 2 would be 145 degrees.
Correct. So this actually is a real one. The thing that I tell students is that when you have parallel lines and transversals, you only have 2 angles. Every angle in this picture, if I want to label these angles, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, we have 16 angles there, but we really don't. We only have 2. We have an acute one and we have an obtuse one. That's all you need to know most of the time when you're dealing with problems about parallel lines. One of them's acute, one of them's obtuse. Clearly that's acute. So this is the obtuse.
Okay.
And the second part is always supplementary.
Okay.
Now, just a side question. I don't ever see this on the test, but if I gave you that and labeled these angles, now notice you can't tell which is the acute and which is the obtuse. They're not necessarily right angles, but just because of the way I drew it, it's hard to tell which one is acute and which one is obtuse. So, tell me the angles that are equal to 1. You know there's still only 2 unique angles. It's just we don't know which yet.
Yeah.
What's equal to 1?
4.
Okay, what else?
5.
Okay, what else?
And 8.
Good. At the vertical angle and the corresponding angles. And then 3 is equal to 6. Its alternate interior. 2 is equal to 7 because its alternate exterior. You notice that the only reason you have to memorize all those rules is in case they give you 2 parallel lines and a transversal that's almost perpendicular. If that 2 parallel lines and transversal is always like that, then you don't have to remember any of that alternate interior or any of that. You have an acute angle and you have an obtuse angle. And it's easy enough. Which is which? I can tell 3 is acute, 4 is obtuse, 5 is obtuse, 6 is acute, 7 is acute, 8 is obtuse. All the obtuse angles are equal to one another. All the acute angles are equal to one another. And this is what you always see on the test. You never see this, where they're almost perpendicular.
Yeah.
Okay? So you really don't need that specific geometry information. You just need to know whether you're looking at an acute angle or an obtuse angle, and they're supplementary. All right. Abigail, I'll let you go. You have a rest of your Wednesday, and I will talk to you next time.
Thank you, you too.
You're welcome.